Honors Geometry, Unit 2, Day 2 notes. Right? Some fun stuff coming here. Right? Stuff I don't know, when I learned this stuff as a geometry student, it just made me feel smarter, just because of the language that is going to be in here. You're going to learn some cool vocab, logic and thinking, and conditional statements. I just like it. But hey, here we go. All right, I'm going to give you some background before we do a handful of Alex questions here at the end to help you with your day 2 practice, which is short and sweet. Okay, terms that you need, and just some heads up here, right? A conditional statement is a statement that could be written as an if-then, okay? The if part is called the hypothesis, okay? And the then part is called the conclusion. Right? If we're gonna symbolically represent this in like the shorthand of, mathematical shorthand of logic here, we always use P for the hypothesis and then Q for the conclusion. So we say, P causes Q, or if P, then Q. And then if we want to say that P's not happening, okay, then we have this little symbol here. If not P, then Q. Or we could say, if not P, then not Q. If this isn't happening, then this isn't happening. Okay, so let's look at some examples to make a little more sense out of that. So here's an example of a conditional statement. It could be written symbolically as P leads to Q. So if P, then Q. Now some vocabulary for you. The converse just means you switch the P and the Q. Whatever the conditional's hypothesis was, put that in the conclusion spot. Vice versa. Whatever the conditional's conclusion was, put it in the hypothesis spot. So Q, then P is the converse. Now the inverse is just kind of a negative little thing. You just take the conditional and you negate the P and you negate the Q. So we would read it, if not P, then not Q. Right? So you just take the hypothesis and you negate it by saying it's not true. So like if the hypothesis is it is sunny today, then negating it would be as easy as it is not sunny today. Okay, pretty simple stuff. The contrapositive, which is very, very important, you'll find out why here in a little bit. The contrapositive is like the converse of the inverse, or the inverse of the converse, because you got to do both. In converse, you switch the P and the Q. In inverse, you negate the P and the Q. The contrapositive, you do both. You switch the P and the Q, and then you negate them. Okay, so it's written in symbolic language. If not Q, then not P. Okay? So when we look at conditional statements, we're going to consider that those conclusions are true. Okay? A hypothesis is a guess. Okay? It says, if this is true, then this is true. Okay, so then this is true, the conclusion, we are assuming in all of our conditional statements that we're going to be studying, we're assuming that those statements are true. Okay, so here's a great example of a conditional statement. If you are in honors geometry, then you are intelligent. The hypothesis, you are in honors geometry. The conclusion, you are intelligent. Okay, let's scoot down. All right, so the converse, we simply switch the if and the then, right? So let's underline the key part of each half of the statement in the conditional. So in the conditional, you're in honors geometry. Let's neaten that up a little bit here. You're in honors geometry. And then the then is, you're intelligent. All right. The only reason we're doing that is so that it's easier just to visualize what you're going to be switching or negating, right? So here we go. The converse will be if, again, you're just going to switch them. If you are intelligent, then you are in honors geometry. You are in honors geometry. Okay, I'll abbreviate to, because this does not allow me to write very small. Okay. Now I'm going to write an inverse of the conditional. Inverse, remember, is we just negate the P and the Q. So we're going to negate you are in honors geometry. So I'm just going to write you are not in honors geometry. If you are not in honors geometry, and we're going to negate you are intelligent, then you are not intelligent. Okay, so we've done the converse, we've done the inverse. Now we're going to do the contrapositive. So we are going to switch and we're going to negate. So we're going to take the Q part, negate it, and switch it. So if you are not intelligent, then, okay, now we're going to take the P, switch it, and negate it. You are not in honors geometry. You are not in honors geometry. Okay, so vocab that you need to know: conditional, converse, inverse, contrapositive. Okay, so now that you know those, question: which of those statements must be true if we are assuming that the conditional is true, which we are? Okay, so let's think about it. If we take for granted that if you are in honors geometry, then you are intelligent, because it is true, then let's look at the converse. If you are intelligent, then you are in honors geometry. So is it true that everyone that is intelligent is in honors geometry? No, that is not true. There are intelligent people that are not in honors geometry. Converses are not always true. They call it a fallacy. Okay? It's not a law, it's a fallacy. Okay? Saying that if you are intelligent, then you must be in honors geometry. It's a fallacy. Why? Well, you may be in honors algebra 2. You may be in AP calculus. You know, you may be a math teacher. Okay, so write the inverse of the conditional. If you are not in honors geometry, then you are not intelligent. Is that true based on the conditional? Okay, so let's take it. If you are not in honors geometry, okay, so we're going to say that's your given. You're not in honors geometry, then you are not intelligent. So that's saying anyone that's not in honors geometry is not intelligent. Well, we just covered that with the converse. No, there are plenty of people that are not in honors geometry that are intelligent. So again, an inverse is not necessarily true. Okay, that's a fallacy. Right? The inverse of a true conditional is not necessarily true. Let's look at the contrapositive. If you are not intelligent, then you're not in honors geometry. Okay, so given you're not intelligent, I'm not saying it about you, but given you are not intelligent, true or false, you are not in honors geometry. That's absolutely true, because we're assuming that this up here is true, that those that are in honors geometry are intelligent. So if you're not intelligent, then you can't be one of those honors geometry people. Okay? So that means the contrapositive must always be true. Okay? If your conditional is true, your contrapositive is true. Okay? Let's say now we got a couple other laws here. In addition to the law of contraposition, because the contrapositives are true, there are two other laws of logic that I want you to know. First one's called the law of detachment, and this is how it goes. Symbolically, you got your conditional statement first. If P, then Q. P causes Q. If P is given, Q is the conclusion, and it's true. Statement 2, P is true. Then, by the law of detachment, my conclusion is Q is true. So let's look at an example. If you enjoy math, then you should join the ELHS math team. Very true. So let's look at it. You enjoy math, that's the P part. You should join the math team, it's the Q part. Ferdina enjoys math. So statement 2 says somebody enjoys the math. So if P causes Q and P is true here for Ferdina, what does that say? The Q part has to be true for Ferdina also. So by the law of detachment, Ferdina should join the ELHS math team. Okay, that's law of detachment. Okay, P causes Q, P is true. Well, then Q is true because P happens to cause Q. All right, law of syllogism. And I've made a note over here. It's very similar to something that you studied back in grade school, the transitive property. They said if A equals B and B equals C, then the A and the C got to be equal, right? So the law of syllogism is just the logic version of that mathematical property. Statement 1, if P, then Q, or P causes Q. Statement 2, if Q, then R. Conclusion, if P, then R. I like to think of this as like dominoes, okay? You have, not Domino's the pizza, even though I like Domino's pizza and everything. But if I had dominoes, say I have domino, 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 okay? Right? So the first domino is P. If P is true, it's going to knock down Q. And if Q is true, it's going to knock down R. So all that's saying is if P gets knocked down, eventually R is going to get knocked down because you got these steps in the middle, or in this case, just Q in the middle, that is going to make it so that the first one causes the third one. Well, here's an example of the law of syllogism. If I don't get enough sleep, then I will put my socks on backwards. Could be true. We're going to assume it's true. So given I don't get enough sleep, conclusion, I will put my socks on backwards. Okay? Statement 2, if I put my socks on backwards, then I'll get a blister on my foot. Notice I don't need the word then, but I mean, you can add then if you want. Okay? So you get your if and your then. So by the law of syllogism, I can say if I don't get enough sleep, okay, then because of the fact that I'm going to have my socks on backwards, I'll get a blister on my foot. Okay? So by the law of syllogism, if I don't get enough sleep, enough sleep, then I will get a blister on my foot. Okay. So if A, then B, if B, then C. So if A, then C. It's kind of like the transitive property that you had before. Okay. So this thingy, the only statements following from a true conditional that must be true follow the laws of contraposition. So the contrapositive is true. Detachment, law of detachment is always true. Or syllogism, law of syllogism is always true. And then a cool fact, this thingy, you can just say therefore. Okay, so the little dot, 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 the triangular dots, it's a therefore. See, does it make you feel smart and all these things? Okay, probably knew it already, but I'm just going to pretend that I'm teaching you that. All right, so now let's look at just a handful of ALEKS questions here that you're going to see in your practice. All right, conditional statements and negations. Okay, complete the following table. Consider the following statement. The water temperature is 65 degrees Fahrenheit. We want to say which of these statements negate that statement. Okay, which ones negate that statement? So a negation down here has the opposite meaning and therefore the opposite truth value. So if your negated statement is true, then that means the thing that it negated must be false. Okay? Go back and replay that a couple of times. You want to follow that. I'm sure it sounded a little wordy, but let's see if we can do an example here. Okay. It is not the case that the water temperature is 65 degrees Fahrenheit. So if this is a negation of your original statement, if it is a negation, then if my negation's true, my original statement's got to be false. So if it is not the case, as it says here, that the water temperature is 65 degrees Fahrenheit, does that mean this is false? Yeah, it does. It's exactly what it says. So that first one is a negation. Second one, the water temperature is not 65 degrees Fahrenheit. So if that's true, does that mean that's false? Well, yeah, it says water temperature is not 65. So I guess the water temperature is 65 can't be true. It's got to be false. So that is also a negation. The water temperature is less than 75 degrees Fahrenheit. Okay, so if that's true, does this have to be false? No. And can you come up with a counterexample? Counterexample means one example where it's not true. The water temperature is less than 75 degrees Fahrenheit. Well, 65 is less than 75. So let's say this is true, but if it's 65 degrees, this is not false. Okay, there's my counterexample. I know right there immediately that that is not a negation because it's not always going to make the original statement false. Okay, and again, that word I gave you, counterexample. Okay, when you're debating someone or you're trying to do a persuasive essay maybe or something like that, a lot of times you're going to want a counterexample, because if somebody says this is always true and you can come up with one time it's not true, you've got the counterexample. All right. Okay, so let's look at this next conditional statement. All right. If the team won its most recent game, okay, the team won its most recent game, then the team is practicing. So this says, what is the hypothesis? Remember, hypothesis is the part that is given, right? It's usually after an if, okay, or it's just the P part of the statement. So the team is practicing. No, that's the conclusion. The team won its most recent game. Yeah, that's what's given. It says if the team won its most recent game, so that's a given. Okay, so the team has not won any games. It doesn't say that. The team is not playing a game. Not saying that. It is not the case that the team won all of its games. Okay, no, it's not saying that. Okay, so we know that the hypothesis is the team won its most recent game. All right. Again, go back to this when you're looking at negations and truth and falsehoods and all that good stuff. Okay? I'm going to keep it right there while we look at the negation of a statement. I believe that's it. Oh, we got one more after that. Okay, so this is the last one on the logic. All right. There are several statements in the table below. For each, determine whether it is a negation. Okay, so is it a negation of this statement or not? That's your question. So remember, for it to be a negation, okay, it has to have the opposite meaning, which means that it has the opposite truth value, so that if your negation is true, okay, or if your negation is true, then your original statement is false. Okay, that's what the vice versa means. And also, whenever this statement is true, your negation's got to be false. Okay, so if one of them's true, the other one's false. Okay, no matter which one is true, the other one has got to be false. There's no way they can both be true or both be false. Okay, they can't both be true or both be false. I said it again. All right, let's see. All right, it is not Tuesday. Okay, does that negate it is Monday? Think about it. If this is true, it is not Tuesday. Does this always have to be false? No, it doesn't, because Monday's not Tuesday. So it is not Tuesday. It could mean something other than the opposite of it is Monday, because it could be Monday. So that is not a negation. Okay. It is not the case that it is Monday. So if this is true, does that rule out the fact that it's Monday? Yeah. Okay. It is not the case that it's Monday. If that's true, then it's not Monday. Okay. So that is definitely a negation. It is not Monday. Well, if that's true, is that false? Yep, it's very false. So that's a negation. And then finally, it is Wednesday. So if this is true, is this always false? Well, yeah, because if it's Wednesday, it can't be Monday. Okay, all the way around. If the original statement is true, if it is Monday, does this have to be false? Well, yeah, it does have to be false. So even though it doesn't have the word not in it, that's a negation too. Okay, again, go back to this statement up here. Okay, whenever the statement is true, the negation has to be false and vice versa. Okay, so the truth value is going to be the opposite. Okay, fun stuff, fun stuff. Okay, all right. So this last question we got, you're going to, we're going to get ready for proofs in Unit 3. And we're just going to do that one more step here, in that we're going to have all of the statements of this type of a proof written, and you just have to provide the reasons. Okay? You just have to provide the reason. So I wanted to make sure that you remembered these from Unit 1. Segment addition postulate. Okay? If I have AB and I have BC and I add them together, then I get AC. Okay? So the pieces of a segment add up to the whole segment. Angle addition. If I take the angle ABD and I add it to the angle CBD, I get this right, CBD. Okay. Then I add those two numbers together, those two measures together, and I get angle ABC, okay, as it says right there. So some of the proofs in this this topic, in this practice, will have segment addition stuff, and some of them will have angle addition stuff. So just a heads up there. Okay, so let's answer these 7 questions. Okay, first, look at the question. Look at the picture and look at your givens. You know that the prove is going to be the very last thing that we want, because that's the end. You're trying to prove it. So that's going to be the very last statement. But we have to come up with reasons. Okay, so number 1, the length of QS, so QS is from Q to S, equals QR plus RS. Well, look at that. That looks exactly like the segment addition postulate. So the reason, and on Alex, you're just going to choose from a drop-down menu here. You're going to choose the segment addition postulate. Okay, right? So we've established this. Great. TU equals TR plus RU. So that looks like the same thing. TU equals TR plus RU. So that also is the segment addition postulate. Segment addition postulate. Okay. So we got a couple of segment addition postulates out of our way. Now it says QS equals TU. So you're going to look at one of 3 places. You're going to look at the givens, you're going to look at the picture, or you're going to look at the statements that you've already written, that you have basically, it's like you're in a courtroom. You've entered these into evidence, so you can refer back to them at any time. Right? So for number 3, QS is equal to TU. Well, look at that right there. It's amazing. It's a given piece of information. So we're just going to select given. That's given info. So now QR plus RS equals TR plus RU. Huh. So look up here. Does it have anything about QR plus RS equals TR? No, it doesn't. Okay. Picture QR plus RS equals TR plus. So, I mean, it looks pretty good, but if you look at what we've got in evidence here, look what you've written. You've already written QR plus RS. Okay. But now you've also got TR plus RU. Okay. Well, that's pretty cool. But how did they get there? They got there from this. Look at number 3. QS. Well, we just said QS equals this. And there it is. TU. Okay. We already said that TU equals this. So they put it here. So they took statement number 3 and they substituted what we had already stated in statement 1 and 2, that those 2 things are equal to, right? So that's just substitution. Okay. See, with the picture up here, they didn't give us that TU is equal to SQ. They didn't give that to us, right? But here they did. So we're not getting this from the picture. We're actually getting this straight from what we have written down in 1, 2, and 3. Okay, so substitution. We substituted what QS is equal to with what TU is equal to. Okay, so now that we're that far, now it says Erase those guys here. Now it says QR is equal to RU. Well, that's not from up here really, but oh look, given, there it is again in the given. So we've got more given information, right? So now we've got QR is equal to RU. Nice. All right. How do you get from statement 5 to statement 6? We'll look back at lines 4 and 5. Okay, let's write them over here just so I have a little bit more room, I guess. For 4, it said QR plus RS equals TR plus RU. But then what did 5 say? It says QR equals RU. Okay, now look at the difference between 4 and 6. 6 says RU plus RS equals TR plus RU. So statement 6 is almost identical to statement 4, except instead of this QR, it turned in an RU. Well, look at statement 5. What did statement 5 say? It says that QR equals RU. So what did they do? They just substituted RU for QR. So they said, okay, QR plus RS, but hey, look, RU is equal to QR. So we're just going to substitute it, right? So that's another substitution. Clever little proof here. Okay. And again, you're just coming up with the reasons. You're not coming up with statements here now. And then finally, what is the difference between 6 and 7? So on 7, you got RS all by itself equals TR all by itself. All right, well, look at 6 here. Okay. Before I erase it up here, what do you notice? They manipulated it so that both sides have an RU. Okay, so if I subtracted RU from this side and this side, oh look, that's step 7. That's the 7th statement. RS is equal to TR, which is what we wanted to prove. So how did we go from 6 to 7? Well, we subtracted the RU from both sides. So that's going to be a subtraction property of equality. I'm just going to write subtraction property. Again, this is going to be a drop-down menu on ALEKS, so it'll be right there for you to see. I believe that's it. It is. That's it. Okay. Unit 2, day 2 is done. I'm going to have you do that ALEKS, and I'm also going to have you create a nice little, I don't know if you call it a puzzle, but I'm going to have you create a challenge problem that deals with the day 1 stuff, with the parallel lines, the transversal, and all those different angles, alternate interior and corresponding, and same side interior, and also I want you to include the triangle sum theorem as well. Okay, so this is it. Day 2 in the books. See ya.